Number 83 in your classwork for circles asks you to determine which of the following statements are always, sometimes, or never true. So we're given a scenario laid out. So we have a circle with a center of P. So we're just going to draw this scenario over here. So we have P at the center. Then RT is a diameter. So RT stretches. Let's redraw this circle. Make it a little nicer. So we have RT and T, and also we have point U is a point on the circle. So let's just arbitrarily put U over here. And so we can now start with the questions. So R of T is greater than RU. So that means this segment R of RT, so the diameter, which is the longest distance across 2 points on a circle, is greater than RU. So of course that'll be true because it says in the problem that U can never be a point R or T. So U will always be, even if it is very close to T, the distance between R and U, if we had this scenario, would still be less than RT because the diameter is the longest distance across a circle. So this one is always true. Now let's look at number 2. So we have measure of TRU, which would be TRU, so this angle is 1/2 the measure of UPT, so UPT, which is this angle formed here. So by the inscribed angle theorem, we do know that if this angle is angle like x, then this angle has to be angle twice the measure, 2x. So this holds always true. Number 3, the measure of RTU. So RTU, which would be, it's getting a little jammed over here, but oops. That would be the measure of this angle. So it is not always necessarily true that that is equal to 90 degrees. And actually, it would never be true, because if RT of U would be 90 degrees, then U would have to be a point actually lying outside of the circle. It would have to be somewhere out here in order to form a 90-degree angle. Even if we had that like limiting case again, where our point is very close to T, right, this angle is always going to be less than 90 degrees. So actually this one is never true. And number 4, we have measure of TRU. So that would be this x again, is 2 times the measure of RTU. So it says that this angle would be twice the measure of this angle, or that one would be 1/2 of x. So is this true? Well, if we have in this case where U is on the circle, so we form a triangle, and we know that this angle will always be a right angle. And certainly if we have a case where x is equal to 60 degrees, then of course this angle would have to be 30 degrees. But let's say that U was closer to somewhere between the 2 points, and we would have that this angle would be 45 degrees. then this angle would also be 45 degrees in order to get the sum to 180. So this is sometimes true. It doesn't work out for every case. And okay, part B, if the measure of PUT, so let's redraw this. So we have the circle again, center P, we have diameter RT, and we have point U. So if PUT, so this angle is 50 degrees, what is the measure of RPU? So the measure of RPU would be this angle, theta. So we know that if we have a triangle formed here, so we have this segment that must be congruent to this segment because they're both radiuses. They're the same measure. We form an isosceles triangle. So that means that this angle at the bottom, again, also has to be 50 degrees, same as this angle here. And that leaves this angle at P. So this angle would be the difference between the sum of all the angles in the triangle. So that's 180 equals 50 plus 50 plus UPT, the measure of angle UPT. So that would be equal to 80 degrees, which means that the measure of theta, because it is a supplementary angle, it lies on a straight line being the diameter. So the supplementary angle to 80 would be 180 minus 80, which is 100 degrees. So the measure of RPU equals 100 degrees.